Alrighty guys, welcome back, and in this video I'm going to be answering all the questions that you guys still have about IP addressing and subnet masking. Because yeah, we learned the basics of it, but now we're looking at this thing, and let's say that this is the IP address of my own computer, and I'm thinking, okay, so somehow I'm supposed to extract the network IP address out of this. I mean, I don't know, do I just like split it right here, or, oh, I use this subnet mask, but that's still kind of confusing. And also, I mean, how many computers are on my network? And whenever I make a network, how do I know what IP addresses I'm supposed to use? And you know what? F it. Forget about networking. I'm done. I'm gonna, change majors, whatever. Well, just a second, and hopefully by the end of this tutorial, everything is gonna be clear. So remember, whenever a computer, in other words a router, sees this information, the first thing that they always do is they convert them to binary. So boom, there it is in binary, and also the subnet mask. Now I don't need to explain how to convert these addresses to binary because we already went over it in the last couple videos, but there you go. So now, okay, so this is my IP address in binary format of my own personal computer, my desktop, laptop, or whatever. So I went to Facebook and I requested a picture of my ex-girlfriend, and Facebook servers found that picture and it sent it back to me. Now it sent it right here to my personal computer. But now when that data gets to the router, it's looking at this IP address and say, hey, I don't care about your personal IP address, I want the network IP address. What network do you belong to? Because that's where I'm supposed to send it. Once it's there, like I said in the last video, it does its thing. So I'll show you guys how to calculate the network IP address and how to extract it from your own personal computer's IP address. So let me just write network right here, and I'll show you guys the easiest way possible. It's incredibly easy. So all you have to do whenever you want to find out what network IP your computer belongs to, write your own IP address on top in binary format, and on bottom write the subnet mask in binary format. Now whenever both numbers equal 1, write a 1. So 1 1, okay, 1. Anytime you see any 0, whether it's top or bottom or both of them, write a 0. So the only time you're going to have a 1 is when both of them equal 1. So this one, both of them equal 1, this one 0, both of these equal 1, 0, 1 1 1, 0 0 1. Okay, this is pretty easy. 1 0 1 0 1 1, yada yada yada, tomato tomato. I actually already wrote it out because I didn't feel like doing it, so let me just pop it up, and there you go. That is your network ID, and of course once we have the binary, we can convert it into a human readable IP address, and there you go. So right here, this, if I can draw properly, is your network's IP address, and this is your own computer's IP address. Alright, so now we know how to figure out the network IP, and yeah, that was a pretty cool math trick, but why the heck does that work? Well, let's think about this. Remember that I told you guys that your IP address is actually broken up into two parts. Part of it is the network's address, and part of it is for the host. Now we already know, thanks to our subnet mask, that can be broken up right here, which means that this part on the left, that's all the network IP address. This part right here, this is for the host. The individual computers on your network are all going to have a different one of these numbers. So now that we remembered that, we can now understand why this math trick actually works. Because whenever we have a 1 right here, what it's essentially doing is it's just copying that part of the IP address. So this part right here and this part right here are always going to be identical. Now whenever our subnet mask has a 0 in it, it pretty much says, yeah, we don't care about this part. You're 1? Yeah, I don't really care. You're a 0 now. You're 1? Nope, don't really care. You're not part of the network IP, so forget about you. And that is how all these networking devices know exactly what network to send that data to. So the last piece of the puzzle I want to talk about is this. Alright, so some servers sent some data to our network. how does that network know which computer to send it to? How many computers are we allowed to have on our network? And most importantly, what IP addresses are we supposed to use on our network? How the heck are we supposed to figure this out? And it's actually really easy. Let me pop this up. So, whenever we have this example right here, we have 16 usable hosts. That means that we can have 16 computers on our network. How do we know this? Well, we know that we have a 32-bit IP address. Now, 28 of those bits are designated for the network, so we can't use those for our host. That means that we have 4 bits that can be designated for devices on our network. Now remember that cool trick I told you guys that anytime you want to figure out how many values you can have, you just use 2 to the how many bits 4, and that equals 16. So whenever you have 4 decimal places, you can have 16 different combinations of 1s and 0s. So that's where we get the 16 different values that we can have for hosts. Now, remember like a minute ago when I told you guys that this means that you can have 16 different computers on your network? I lied. And that's because you always need to reserve 2 IP addresses for special occasions. The first one is your network IP. I mean, you just can't have this IP assigned to a device on one of your computers because this is actually the network's address. So that takes away one right there. And also the very last IP address on your network, it's a special broadcast IP, and I don't want to get into that right now because I'm sure I'm overloading you with information right there. But again, 1 for the broadcast and 1 for the network IP address. Now the rest of those IP addresses you can just assign to any computers, your laptop, your phone, your desktop, whatever. So again, this is your starting point right here, and you own 16 IP addresses that follow that. So 141.0, 141.1, 141.2, all the way to 15. Because remember, 0 to 15, that's how we count. We start with 0 instead of 1, so it's not 1 to 16. So there you go. So these are your usable hosts. The first IP address that you can actually assign to a computer is 169.174.141.1. And you actually have the IP addresses all the way to 15, but 15 is that special broadcast one, so you can use all of these from this one to this one right here. So there you go. All of that we found out with this bit of information. Pretty stinking amazing, eh? Now I just want to go over one other example really quick, just to pound it in your guys' brain. So whenever you want to figure out the network IP address, all you have to do is convert your IP in your subnet to binary, and remember, you do that little 1 trick, so 1 right here, 1 right here, all the way into, let me pull it up, boom, there you go. So that's your network's IP address in binary format. Let's go ahead and turn that back into a readable format. And once we have this information, then let me just say, okay, so this is the network portion of your IP address. This is the host, and what that means is that we have, let's see how many bits, 10. So 2 to the 10 is going to give us that. Remember to reserve 2 for the network IP and the broadcast, and that means that we have all of these IP addresses that we can use for computers on our network. So pretty awesome. This little chunk of the internet, from here to here, it belongs to us. Pretty stinking awesome. And you know what? I decided to give you guys a homework assignment just to make sure that you guys understand everything that's going on. So this is the IP address right here, and this is the subnet that I gave you. Your job is to give me the network IP. And also for bonus points, what you can do is give me the usable host, the IP addresses that you can actually assign to computers, and you can just leave your answer in the comment section below. And a couple parting thoughts I want to point out. Say that you have an address like 108. I don't know, just make it stupid, 2.2.74. Now you know a subnet mask is always a bunch of 1s followed by a bunch of 0s. Sometimes you may see the notation right after the IP address, people write 20. This is just a shorthand version of writing the subnet mask. So this means that I'm going to write 21s and then the rest are just zeros. And this is actually called CIDR notation, CIDR. And the last thing I want to point out is the maximum size of your network ID can be 30 bits. That's the maximum number of ones that you can have in your subnet mask. And if you think about it, you can't have 32 because an IP address is 32 bits. And if you made the entire network 32 bits, that means that you're trying to make a network with no hosts on it, with a network without any computers. Now, if you made it 31 and you reserved 1 bit for the host, that means that you're trying to make a network with only 1 computer on it, and that's not a network, that's just a computer sitting by itself. The definition of a network is, computers connected together. So, just some parting words of wisdom for you guys. But anyways, there you go. That's your homework assignment. Leave your answer in the comment section below. The first one to get the answer right, they actually get no prize, but it'll be pretty cool. And also, if you guys have any questions at all about anything, ask me on my forum. I don't really check the YouTube comment sections that much. So in my forum, on my website, there's a bunch of people willing and able to help. So there you go. See you next video.